The year was 1991, the night of January 17th. Deep inside a Soviet-built air defense center in the heart of Baghdad, an Iraqi radar operator stared at his screen. Everything was normal. The sky was completely empty. No threats were visible. Then the world exploded. A command center a few kilometers away transformed into a massive fireball. The operator ran to the window in shock. There was nothing in the sky. There was nothing on the radar screen. But buildings were exploding one after another. That night in Baghdad, the most advanced Soviet air defense system was operating at full capacity. Hundreds of radars, thousands of missiles, tens of thousands of soldiers, and none of them could see a single American aircraft. The Iraqis thought they were fighting ghosts. They were not wrong. This is the story of how America built an aircraft that broke the laws of radar physics, and how the Soviets discovered that their trillion-dollar air defense network was worthless against a shadow. To understand the shock of that January night, you must first understand what the Soviets had built. After the Second World War, the Soviet Union became obsessed with air defense. American bombers had devastated Germany and Japan. Soviet planners knew that in any future war, American aircraft would try to do the same to Moscow. They responded with the most ambitious air defense program in history. By 1990, the Soviet Union and its allies had constructed a network of over 10,000 radar stations. They had deployed more than 12,000 surface-to-air missile launchers. They had trained hundreds of thousands of personnel. The crown jewels of this system were the SA-2, SA-3, and SA-6 missile systems. These weapons had proven themselves in combat. SA-2 missiles had shot down Gary Power's U-2 over the Soviet Union in 1960. They had destroyed dozens of American aircraft over Vietnam. The SA-6 had devastated the Israeli Air Force in the 1960-73 Yom Kippur War. Soviet military doctrine was built on a simple principle: quantity has a quality all its own. They could not match American technology one for one, but they could build so many radars, so many missiles, so many guns that no aircraft could survive the sheer volume of fire. Iraq had purchased this philosophy wholesale. Saddam Hussein had spent billions of dollars importing Soviet air defense technology. By 1990, Baghdad was protected by one of the densest air defense networks outside the Soviet Union itself. Soviet advisors had personally supervised the installation. They had trained the Iraqi crews. They had integrated the systems into a unified command structure. They were confident in their work. No aircraft can penetrate this network, they told the Iraqis. If the Americans attack, they will lose dozens of planes on the first night, perhaps hundreds. They were about to be proven catastrophically wrong. While the Soviets were perfecting their air defense network, something strange was happening in the Nevada desert. In 1977, a top-secret program began at Lockheed's Skunk Works facility. The same engineers who had built the SR-71 Blackbird were working on something even more revolutionary: an aircraft that radar could not see. The project was codenamed Have Blue. Later, it would become Senior Trend. The aircraft it produced would be designated F-117, but the pilots who flew it would simply call it the Nighthawk, or sometimes the Ghost. The concept behind stealth was not new. Engineers had understood for decades that an aircraft's shape affected its radar signature. Curved surfaces reflected radar waves back to the receiver. Flat surfaces could deflect them away. But turning this theory into a practical aircraft seemed impossible. The mathematics required to calculate how radar waves would bounce off complex shapes was beyond the capability of human engineers. There were simply too many variables. The breakthrough came from an unlikely source: a Soviet scientist. In 1964, a Russian physicist named Pyotr Ufimtsev published a paper on the diffraction of electromagnetic waves. He had developed mathematical equations that could predict how radar waves would interact with different geometric shapes. The paper was theoretical, obscure, and seemingly useless for military applications. The Soviet military ignored it. They saw no practical value. But an American engineer named Dennis Overholtzer read the translated paper and realized something extraordinary. Ufimtsev's equations could be programmed into a computer. For the first time, engineers could actually calculate the radar signature of an aircraft before they built it. The irony was profound. The technology that would defeat Soviet radar was based on Soviet mathematics. The F-117 that emerged from Skunk Works looked like nothing that had ever flown before. Traditional aircraft were designed with curved surfaces for aerodynamic efficiency. Smooth lines, rounded edges, shapes that slipped through the air with minimal resistance. The F-117 threw all of this away. Its surface was made up of flat panels set at precise angles, sharp edges, straight lines. It looked less like an aircraft and more like an angular black diamond. Some engineers joked that it looked like a spacecraft designed by ancient Egyptians. This bizarre appearance was not aesthetic, it was mathematical. Every single angle on the F-117 was calculated to deflect radar waves away from the transmitter. The flat panels acted like mirrors, bouncing the radar signal in every direction except back to the receiver. The result was an aircraft with a radar cross-section smaller than a bird. On a radar screen designed to track aircraft, the F-117 appeared as nothing more than noise, background static, invisible. But making an aircraft invisible to radar was only half the challenge. The other half was making it actually fly. The F-117's angular shape was aerodynamically unstable. It wanted to tumble out of control. No human pilot could possibly react fast enough to keep it in the air. The solution was computers. The F-117 was one of the first fly-by-wire aircraft. 4 onboard computers made thousands of corrections every second, constantly adjusting the control surfaces to keep the aircraft stable. The pilot gave commands, but the computers actually flew the plane. This was revolutionary in 1977. The Soviets had nothing like it. They were still building aircraft that relied on mechanical controls and aerodynamic stability. The Americans were building something from a different era entirely. If you want to discover the secret technologies and untold stories of the Cold War, subscribe to our channel. We bring you new content every week. The F-117 first flew in 1981. It was immediately classified at the highest level. The pilots selected to fly the Nighthawk were sworn to absolute secrecy. They could not tell their families what they flew. They could not tell their friends. Officially, they were assigned to a unit that did not exist, flying an aircraft that did not exist. Training took place only at night. The F-117 was never flown during daylight hours. If a pilot had to land during the day due to an emergency, ground crews would immediately cover the aircraft with tarps and surround it with armed guards. The Soviets knew something was happening. Their intelligence agencies reported unusual activity at the Tonopah test range in Nevada. They obtained blurry satellite photographs of strange angular shapes on the tarmac. But they could not believe what they were seeing. Soviet engineers analyzed the photographs and dismissed them. This shape cannot fly, they concluded. The aerodynamics are impossible. It must be a decoy, a deception program designed to waste our intelligence resources. For nearly a decade, the Soviets convinced themselves that stealth aircraft were American propaganda. They had no frame of reference for an aircraft that computers kept in the air. They could not imagine that their own scientists' equations had made it possible. This arrogance would cost them everything. January 17, 1991, 2:43 in the morning, Baghdad time. The first wave of F-117 Nighthawks crossed into Iraqi airspace. There were 36 aircraft in total, approaching from multiple directions. The Iraqi air defense network was fully alert. Radar operators were at their stations. Missile crews were standing by. Fighter aircraft were airborne. Everyone expected the Americans to come. They never saw them arrive. The F-117s flew at medium altitude, around 20,000 feet. They were not trying to fly under the radar, they were flying through it. The radar beams passed over them and around them, but almost nothing bounced back. On Iraqi radar screens, the sky appeared empty. Just static, background noise. The first bomb fell on the Iraqi Air Defense Operations Center at 2:51 in the morning. It was a 2,000-pound laser-guided bomb dropped from directly overhead. The building vanished in a massive explosion. The Iraqis did not understand what had happened. There was no warning, no radar contact, no missile launch alert, just sudden, total destruction. Within minutes, explosions were erupting across Baghdad. Communication centers, command bunkers, radar installations, power plants. Each target was hit with surgical precision. Iraqi gunners fired wildly into the sky. They had no targets. They were shooting at ghosts. Tracer rounds arced into the darkness, hitting nothing. The few Iraqi fighters that managed to take off flew in circles, searching for enemies that their radar could not find. Some pilots reported seeing brief flickers on their screens, but by the time they turned to investigate, there was nothing there. By dawn, the F-117s had returned to their bases. They had flown over 1,000 sorties during the war. Not a single F-117 was lost to enemy fire. Not a single one was even hit. The reports that reached Moscow in the following days were devastating. Soviet military advisors had been present in Baghdad. They had witnessed the attacks. They had seen their vaunted air defense network fail completely. Now they had to explain to the Kremlin what had happened. The explanation was almost impossible to accept. "The Americans have an aircraft that our radar cannot see," they reported. "Our missiles cannot lock onto it. Our guns cannot track it. It flies through our defenses as if they do not exist." The implications were catastrophic. The entire Soviet military strategy was built on the assumption that they could deny airspace to enemy aircraft. Their ground forces were designed to operate under the protection of dense air defense networks. Their navy relied on land-based air cover. If American aircraft could penetrate these networks at will, everything changed. Soviet engineers scrambled to understand the technology, studied every piece of intelligence they could gather. They analyzed the wreckage of bombs and missiles. They interrogated the mathematics of radar reflection. Slowly, painfully, they began to understand. The F-117 was not using some magical cloaking device. It was using geometry, pure, simple geometry that their own scientist had described decades earlier. The flat panels, the precise angles, the radar-absorbing materials. Each element worked together to minimize the radar signature. The aircraft was not invisible. It was just extremely small on radar, small enough to hide in the noise. The Soviets realized they had made a fundamental error. They had assumed that stealth was impossible because they had never seriously tried to develop it. They had dismissed Ufimtsev's work as theoretical nonsense. They had laughed at the photographs of angular aircraft in the Nevada desert. Now the joke was on them. The science behind stealth is elegant in its simplicity. Radar works by transmitting radio waves and listening for reflections. When a radio wave hits an object, it bounces back. The radar receiver detects this reflection and calculates the position, speed, and size of the object. The key insight of stealth design is that radar reflections are not equal in all directions. A curved surface, like the fuselage of a traditional aircraft, reflects radar waves in many directions, including back toward the transmitter. This creates a strong return signal. A flat surface, angled correctly, reflects radar waves in a single direction. If that direction is not toward the receiver, the radar sees nothing. The F-117 was designed so that every external surface was angled to deflect radar waves away from the most likely receiver positions. The flat panels created a series of controlled reflections, each pointing harmlessly into empty sky. The sharp edges might seem counterintuitive. In traditional thinking, sharp edges create strong radar reflections. But Ufimtsev's equations showed that the reflections from edges are predictable. Engineers could calculate exactly where the edge reflections would go, and designed the aircraft so they pointed away from threats. The result was an aircraft with a radar cross-section of approximately 0.001 square meters. For comparison, a traditional fighter aircraft like the F-15 has a radar cross-section of around 25 square meters. The F-117 appeared on radar as something about the size of a marble. In the clutter of a radar screen, it simply disappeared. The shape was only part of the stealth equation. The F-117 was also covered in a special material known as radar-absorbing material, or RAM. This coating was composed of iron ball paint and specialized polymers. When radar waves struck the surface, the material converted their energy into heat instead of reflecting it. The coating literally ate radar signals. Applying and maintaining this coating was extraordinarily difficult. The material was toxic. It degraded in sunlight. It had to be applied with microscopic precision. Any gap or imperfection would create a radar reflection. Ground crews spent more time maintaining the stealth coating than they spent on the aircraft's engines and flight systems combined. A single F-117 required thousands of man-hours of maintenance between missions. The Soviets knew about radar-absorbing materials. They had experimented with similar coatings, but they had never successfully integrated them into a production aircraft. The manufacturing tolerances required were beyond their industrial capability. This was a pattern that repeated throughout the Cold War. The Soviets could understand American technology in theory. They often could not replicate it in practice. Their factories were designed for mass production, not precision manufacturing. The F-117 was not a mass-produced weapon. Each aircraft was essentially hand-built. Only 59 were ever manufactured. But those 59 aircraft changed the course of military history. The F-117 flew its last combat mission in 2008. It was officially retired from service, replaced by newer stealth aircraft like the F-22 Raptor and F-35 Lightning. But the legacy of the Nighthawk extends far beyond its operational career. The F-117 proved that stealth worked. Not in theory, not in simulations, in actual combat, against actual Soviet-designed air defenses, in the most heavily defended airspace on Earth. This proof transformed military aviation. Every major air force in the world now prioritizes stealth in their aircraft designs. The United States has built an entire fleet of stealth aircraft. The B-2 Spirit bomber, the F-22 Raptor, the F-35 Lightning, the B-21 Raider. Russia and China have scrambled to develop their own stealth aircraft, decades behind the American programs. They are still trying to catch up to technology that America deployed in 1983. The F-117 also transformed air defense. The failure of Soviet systems in the Gulf War forced a complete rethinking of radar technology. Modern air defense systems use multiple frequencies, multiple angles, and sophisticated signal processing to detect stealth aircraft. The invisible war between stealth and radar continues today. Each advance in stealth technology prompts a response in detection technology. Each improvement in radar prompts a response in stealth design. But the fundamental advantage remains with stealth. It is always easier to hide than to seek. The mathematics of radar reflection favor the aircraft designer, not the radar engineer. The story of the F-117 is ultimately a story about assumptions. The Soviets assumed that quantity would defeat quality. They built thousands of radars, thousands of missiles, believing that sheer numbers would overwhelm any attacker. They assumed that their own scientists had nothing important to teach them about radar. They ignored Ufimtsev's work because it seemed impractical. They assumed that the strange angular shapes photographed in the Nevada desert could not possibly fly. They dismissed the evidence of their own eyes because it contradicted their beliefs. Each assumption was wrong, and each wrong assumption cost them dearly. The F-117 was not built by geniuses working in isolation. It was built by engineers who paid attention, who read obscure scientific papers, who questioned conventional wisdom, who were willing to build something ugly if ugly worked better. The Soviets had the same information available. They had better information, in fact. Ufimtsev was their scientist. The equations were published in Russian first. But they did not see what the Americans saw. They did not imagine what the Americans imagined. And on the night of January 17, 1991, they paid the price. The ghost flew through their trillion-dollar shield as if it did not exist. Because against stealth, it did not.